So UML is really more like a set of types of diagrams than a language. It's not like a programming language, but it is a set of notations for describing various structures in an object-oriented system. There's a zillion different UML diagrams, but the most common kind, which we're going to use a lot, is the class diagram that shows the class relationships, and sometimes it shows some of the most important methods in the class. So what kinds of things can you put into a class diagram? So the open arrow is an inheritance relationship that says that car is a subclass of vehicle. It inherits from it. A solid arrow says that this thing is a component. So an engine is a component of a car. What does that mean? That among a car's various attributes, one of the attributes is an engine. In this we've shown that a couple of the important methods of the engine are start and stop. You don't necessarily have to list a lot of methods here. I find that the diagrams get sort of pretty bulky pretty fast. So we can use them to represent relationships along the lines of the ones that we've been talking about, like has many and belongs to. So this is a somewhat complicated diagram, but it's actually not that bad once you unpack it. One kind of relationship is called an aggregation. That's usually an open rectangle, but I'm not going to take off points if you forget which one is an open and which one is a solid diamond, because I always forget myself. But basically this says this is a relationship in which the child can exist independently of the parent. So whatever an account code is, there's a mapping between one account code and 0 or more items. Okay, so if we said it another way, we could say account code has many items. Item belongs to account code. And the open diamond technically is supposed to mean that even if account code did not exist, it would still make sense for item to exist. The other kind is the one with the solid diamond. And about half the time I teach this class, I reverse which is correct. So that's why I'm not going to penalize you if you reverse it. Same idea. One of these has many of these. One of these belongs to exactly one of these. The difference here is that the solid diamond supposedly means that it doesn't make sense to talk about only the child in the absence of the parent. So in this case, the relationship is a customer has many items. An item is a thing that the customer can buy. But it doesn't make sense to talk about an item if there's no customer that bought it. So it's a subtle distinction, and I will never take off points on an exam for anything like that. But you may see both open and solid diamonds, and now you know. The more relevant thing is the numbers at each end of the arrow, which is the cardinality of the relationship. Right? One of these maps to 0 or more of those. One of these maps to 0 or more of those. One of these maps to 1 or more of those. Right? So here's a scenario in which if this thing exists, then it is guaranteed or it's necessary that at least one of these things exists, but there could be more, 1 up to asterisk. Excuse me. And again, an example of inheritance. In this diagram, whatever an item is, 2 things that are subclasses of it are donations and vouchers. So either of those has a strict subclass relationship. We'll talk a lot more about subclasses when we do solid class design. So, and by the way, this diagram was actually automatically generated for me. There's a gem that you can use, and I'll put it in the slides, that will essentially walk through all of your model files and database tables, and it will draw this. If you're working with legacy code and you're trying to understand which are the most important models, that could be a really useful diagram to have. So, by the way, these are all the different kinds of UML diagrams. We're not going to cover the other 85 kinds. I just want to be able to get it so that when we're talking about classes, whether it's active record models or something else, we can easily talk about the relationships between classes. So why does this much matter? This matters because we can now sort of introduce a sort of really low-cost way of thinking about the design of your app at the level of classes. And not every class in your app is going to be an active record model, but a lot of them probably are, because the models are the entities the app manipulates. It's kind of where most of the action happens. So to do that, we're going to introduce this really simple mechanism that, again, came out of the Agile movement called CRC cards for class, responsibility, and collaborator. And the idea is really simple. For every class defined in your app, whether it's an active record model or something else, you should be able to answer 2 questions. What are the things that it knows? and what are the things that it's responsible for doing that it might have to collaborate with other classes on. So this is an example based on the previous slide where we could say an order is a class that knows how many tickets are in it, but that implies that it has to collaborate with some other class that maybe is called ticket. An order knows how to compute its own price. That doesn't sound so bad. An order knows who owns it. Oh, sorry about the duplication of that line there. An order knows who owns it, but that implies that there must be a class representing a thing that can own an order, so we're going to call that patron. Similarly, a ticket, well, a ticket certainly knows its own price. It knows which performance it's for. Okay, well, that implies that there is some class somewhere that models the concept of a performance, so ticket would have to collaborate with it. It knows whether it's available, is someone sitting there, and it knows if someone is sitting there, it knows who the patron is. So again, it implies that there is a class representing what the owning relationship is. And one way that you can come up with these, so the idea is that each one of these cards will probably map to a model in your app. And whenever there's a collaborator, that suggests that there's going to be some kind of relationship, like has many or belongs to, between those different models. Maybe it'll be a relationship that ends up going through a third class, like those many-to-many. So this is sort of an intermediate step before you define classes to say, which classes do I actually need, and which ones are going to have some relationship to each other. So how do you get to the point of even being able to draw this? Well, you could just sort of sit down and try to do it, but we found that an easier way to do it is to start from the user stories that you already have. So for example, if one of your user stories was something like this, adding movie tickets to a shopping cart, so as a patron, so that I can attend a showing of a movie, I want to add tickets to my order. Basically, go through that three-line part of your user story, identify the nouns, and identify the verbs. Nouns are probably models or relationships between models. Right? So for example, there's a ticket and there's a showing. OK, those are clearly models. Are those models related to each other? I don't know. Maybe there's an intermediate model. Because a ticket, I don't know, if a ticket could be valid for many different showings, but a showing has many tickets, maybe there's an intermediate model relationship. We're not sure. But tickets and showings certainly are things. And there's probably going to be a relationship between them. Verbs tend to be things that one of the models is responsible for. So as a patron, so that I can attend a showing. Attend is a verb. So somewhere in one of the models implicated in that statement, there's going to be a method that means make it so that this ticket is set to attend or be valid for that movie. Similarly, I want to add tickets to my order. Well, that implies at least three things. Tickets are a thing, an order is a thing, and adding tickets to an order is a thing. Now, we haven't said who is responsible for adding tickets to an order. Is it the case that you have the order and you give the order some tickets and say add these? Or is it the case that the ticket can support a method that says, here, add yourself to this order? We don't know. We haven't gotten that far. But this helps you identify what the main classes are likely to be. Right? Roughly speaking, nouns will probably end up as classes. There may be additional classes that model relationships between those nouns. And verbs will end up as method calls in one or more of the classes that actually make the things happen. So this is not a foolproof way. You're not going to get 100% of your classes and methods out of this, but it gives you a starting point. And it gives you a starting point that is based on a document that you already have, which is the user story. What do your colleagues have to say about this approach to app design? Again, this is from our top 10 list. This was number 2. Actually thinking about this stuff before you sit down and start writing code and creating migrations saved a lot of pain. That if you actually think about this stuff carefully, you can separate out your models nicely. We had a couple of teams where there was a team designing a client piece and a team designing a server piece, long story. But being able to figure out the division of responsibilities using this method allowed each team to sort of proceed in parallel without stepping on each other's toes. And the teams that hadn't really thought about this ended up wishing they had, because what happens if you don't design the object model properly is you find yourself having to implement some user story and there's no place to put it. There's no place for the functionality to live. The user story says, the user can do A to B, but you don't have an A or you don't have a B, and you have got no place to put the functionality of doing A to B. Does this mean that if you design your object model thoughtfully in iteration 1, you will never change it again? Almost certainly not. You will almost certainly end up evolving the model as you go, especially if the user asks for more features or more functionality later on that were not foreseen when you did the first round of planning. That's OK. You do the best that you can with the information you have. But spending some time to actually draw the little pictures, you could actually use little index cards to do the CRC cards. And then when you have gone through all of your user stories and you've got no cards left to add, or you've got no responsibilities or collaborators left to add on a given card, then you're done, right? At that point, you have enough functionality and enough class relationships to implement that set of user stories. So that is what I would suggest you do.